Okay guys, welcome back to Pure Math School, and today we are going to go through our third video of the channel, and we're going to basically today look at questions that actually can cover the first two things we handled in the previous two videos. And let me just kick off. Our first question for today, we're going to just state the following, whether true or false. Yep. And the first one you can take a look at, we have 4 greater than 5. And for this, when you have something like this, you remember we have to reflect back to our number line. 0, -1, -2. Then we have 1, 2, 3, 4, 5, 6. Remember we said that in our first video, a number which is always on the right is always bigger than one on the left, and that's what we can use to know what. And if you see, if you maybe stand in the middle of 4 and 5, 5 is on the right and 4 is on the left, that means 5 is actually greater than 2, and that makes this to be false. Another simple question you can look at, let me say -3. We say that still from here we have -3 somewhere here. So if you can see, basically -3 is on the left if you maybe stand in the middle of them, and -2 is on the right. That means -2 is actually bigger than -3. Numbers on the right are always bigger than numbers that fall on the left. That means it's also false. I think from there you can get how to handle something like that. Maybe something you can try out. 5 that maybe let me say that you can try this out, these two out. We take a look at another. Let's say under that we can mean E. Let's take something a bit more further. Let's take on, let's say x is positive, a set of positive integers, and we put some special condition or rule, x not being that 3 and 2. In case I list this, let me say I give this as a answer to that solution set. 6, let me say 7, 8, 9, and so on. So as you know from our number line, positive integers are the same as natural numbers or counting numbers. That's the basic one we know. And we have 0 here. Positive integers are natural numbers or counting numbers, and once we know that's from 1 onwards, 2, 3. So positive integers start from here up to the other side. So we have to see, but the rule they put, we should not include 2 and 3, x not being equal to 2 and x not being equal to 3. So that means we see if this satisfies that. Positive integers, we have 1, that's okay. 2 has been skipped, 3 has been skipped also in that. We have 4, 5, 6, 7, 8, and it's going on. Since they have skipped 2 and 3, you can say this set is, this case is true one. And we can take a look at another condition. Let's say let's take for this in case to be a real number, and we say -2 less than x less than 5, and we list as this. Let me say -1, 0, 1, 2, 3, 4, and 5. Maybe stop there. Now if you see that in this question, we have to remember what we said, real numbers. We can't actually basically list all real numbers. Why? Because real numbers have both rational and irrational numbers together that form a real number, which makes a set. So in this number line, you know that there are fractions in between, which some fractions are rational, others are irrational. But this number line basically shows us only integers. And so by that means by the time you can list this listing below here are only integers. I have to say that you can't list a set of real numbers. You'd rather leave us a solution set like that in case you come across a solution like that. So for that case, we can say this is false. And I can leave out something for you to try out. You try out this, or x less than equal to 2, saying is equal to x in R, x less than 3, less than 3. You can try that out. Then another number I can give, let me say an integer of -2 less than x less or equal to 5, being 91, 0, 1, 2, 3, 4, 5. You have to be careful here. You have to notice that here for you to know that, and here you also need to know that this can be equivalent to this based on how you've realized. And if you can see here, this sign, that means 3 is not included. Could be you're going to try out and see how that one can come out. And let's go to another set of numbers, another set of questions we can look onto today. That's question 2. We can list the elements of the following: A, let me say x being an integer, -2, this rule is here, less of a, not only less than 4. So if we are to list this, x is an integer, that means all the normal, the positive and negative integers, including the 0 on a number line. We have -2 here, but we're not going to include, because remember there's no equal sign and beneath this less than sign even here. So negative, basically remember we had this or that. This means closed, this one open, and this is closed, and that means we don't include the numbers close to that. So that means we are not going to include -2 and 4 as well. So that means since they're integers, the next one near -2 on the right would be this. We have here -3, -2, -1, 0, 1, 2, 3, 4. So you see that we would skip this, we would put it there and there, but that would mean we would not include this, and that we consider this one here. So we have our listing become -1, 0, 1, 2, 3, 4. Sorry, we are not including 4. Sorry. Yeah, we are not including 4. So we stop here. We can check on another one. Let me say set of integers -3 less or equal to x less than 2. Here we know we are going to include 3 because of this less or equal sign. We are going to include -3 this, we would have a closed circle on 3, and here, since there is no equal, we would have an open circle on top of 2. Then we join those two, so we include this but exclude 2. So we have -3, -2, -1, 0, and 1. We stop there. We're not including 2 since 2 has no, it's not having a closed circle. Maybe another number you can try out now for yourself. X being a positive integer for x less than 5. And another one, let me say x being an integer for such that -3 is less than x less or equal to 2. You try out on those ones. Maybe you would comment in the video and I try to see what you put in the video. Another set of number of questions we can look at today. Let me say, give the following sets of numbers in the form x being a set of numbers such that x satisfies some inequality or rule. We can look at numbers of that nature. This being a set, that's a set of numbers would be natural, real, could be integers, positive, negative, rational, or irrational numbers, and satisfying some inequality rule. And first we can look at, let me say, -3, -2, -1, 0, 1, and 2. So if you're going to give, that means this one is actually how a solution set, the form of a solution set. So if you are to express in form of a solution set, you're going to say, remember we said whenever you're not specified and they've not told you that it's a rational number or you take it to be integers, we always assume that it's a real number. Like in our previous video, I remember talking about that. We have to assume that is now for a set of maybe real numbers in case not specified. But here we can't see. Here everything, we have every number there, and we know all these are integers which are in a number line since they have listed them. So we can say x being set of integers such that x, we have -3 included. The stretch of numbers from -3 and to 2 is included, so we could just have -3 here, and we have numbers here and 2 here. Since they included, you put that closed circle here, you join, and you realize you have x between -3. We have included -3 and we have included 2. You could just write like that. That would be a solution set for that. Or you could even decide maybe to start from maybe a number beyond -3. Let me say -4, and here 3, and you say x being an integer such that 94 is less than x less than 3, and not including. That means you're not including 4 and not including 3. You could do it in various ways, or could even, let me say, here you put 2 this side and you put that. You could do it on different ways to express that. You can even have more as you look, or maybe you try to check on that by yourself. Yeah, and I think I'll give you some few examples you can try out. Try this out for yourself. Give a solution set for that. Maybe this also. 94, 93, 92, 91, 0, 1. In math, we always have to have 3 dots, meaning so on. So we have that. You try this too. You have to know that this infinite from the negative side. That means you be careful. Can never be an integer, since could be a set of integers that, but you have to be careful of -4. I don't know how you're going to. You have to understand what these three dots mean, extending from a negative side to infinity. You can start here and just try if maybe to include that in a number line would be better for you to realize that. Try that out. Yeah, check in the comments. Another one we can see is maybe is this one, still under the same kind of question, still expressing as a set of as a solution set. Now we try to look at a question which has a number line. Let me say D. You have -5 here, -4, -3, -2, -1, 0, 1, 2, 3, 4, and they'll put, let me say closed circle is on -1 and stretching the other side. If you know our closed circle means, we would include -1 and go on, and this you know figures on the right of -1 are always bigger, so that means our solution set would actually be x being an integer such that x is greater or equal to -1. Since we have included -1 there, we have to include that. The closed circle, you know, that would come. One more about that. Here you have 0, 1, 2, 3, -1, -2, -3, -4, -5, and now you let's say we have a number line. Now let's say you have a maybe an open circle on -1 again, but still stretching that side. You see, this time you're going to exclude this, so we need to just write our solution set as x being greater than -1. We are not including because it's an open circle, so you have something like that, close to that. I can give you, let me say, something to try out. 1, 2, 3, let me say here, -1, -2, -3, -4, -5, and I put a closed circle here. I join the 2 points. Yeah, you come out with that. You know what I mean? If you have 2 closed circles at the end and being joined by a line, you can interpret that, since I covered already in the previous lesson. I think we can shift to another form of set of questions. Simplify each of the following inequalities and show and draw show on a diagram for each solution set, x being a real set of numbers. A, you have 2, that. Simplifying that, the only thing we remain with, we have x on one side and figure 6 on the other side. We just make x alone by dividing through by 2. So you have by 2 here would remain with x, and by 2 here would remain with 3. We're dividing by a positive number, so no need to change our sign. Putting that as a solution set would be the same as this, x in R for x being less or equal to 3. That's simple. And on a number line, You have here, let me say 4 3 2 1 0, -1, -2, -3. Then we are starting from 3 close, because 3 is included because of this equal, a less or equal sign. Then that then we look at another number. We have 2x minus 4 being greater or equal to 1. Here we take 4 the other side, we have 2x, we add 4 here to remove it, and also do the same the other side so that we don't cause change. That means here if we add 4, we're going to have 5, and x will be greater or equal to 5 out of 2, which is the same as 2.5. If you see here, divide by 2, here goes 2, by that 4, then the remainder will be 1, so it's 2 and 1 out of 2. So as a solution set, you'd see that written as x in R such that x is greater or equal to 2.5. On a number line, there'll be a 0, -1, -2, 1, 2, 3, 4. Then half here in the half of 2 here, 2.5 before 3. We have a closed circle because of this sign. Then greater going that side. Yeah, I think the number is done. And I can give you one number where you can try out. Let me give you a C. You'll try out C on your own. 85 less or equal to 2x minus 3. That's equal to 7. Now the solution set would be 91 s or equal to x, s or equal to 5. This would be the solution. You try it out and try to reach there, and you can comment in the video and I see how you've done it. I'm going to maybe the last batch of questions for today. Find the solution sets of the following: inequalities. The first one you can look at now. This one is going to help us handle the last part we handled in the previous video, which is the modulus here. And if you remember our note, the note under in our previous video, you can check it. It's inequalities. The one we looked at, we handled this, and we said for less than, we had two scenarios: when x, modulus of x, is less than a, and when modulus of x is greater than a. And this would also apply for that, this would also apply for that, and the same thing. We noted conditions that satisfy this. For this, it was that this x should lie between positive value of a and negative value of a, while for this, x was supposed to be greater than the positive value of a and or less than the negative value of a. So that's the same thing we're going to apply here. Since we have this, which is less, we're going to consider x minus 2 must lie between the positive value of 5 now and negative value of 5, and we solve that. Then here we have, here we remove 2 here, that means we are adding 2 everywhere. If we add 2 here, we're going to have here -3 less or equal to x, because 92 plus 2 remove it, less or equal to here 7, and that would be our solution. And if we show it as a solution set, we are going to have x in let me say R. They have not specified here, so we assume to be R. Then -3, x is lying between -3 and +7. That's a solution set that can be for that. The next question you can see now is 2x minus 1 being less than 5. That's the same kind of question with that. You can try that out, and your solution set you must reach 2 must be negative 2 less or equal to x less or equal to 5. That's a solution set you should come with. You're now writing this form for it. That will be your solution. And now let's try to look at another form, the one that covers this one here. Let me say 2x minus 5 greater than 7. So, and also, by the way, there was another method I used in my previous video. You can check that. That's inequality under inequalities, how to solve this and how to reach there another way. But you can check that in my previous video. You just type pure math school and you'll get the videos under there. The second video, which is 0.2. And now here I have this. I'll apply this. That means either 2, which is all of that, 2x minus 5 should be greater than the positive value of this, which is 7. That's taking the place of our a, so that we have 2x minus 5 plus 5 to remove, but we do the same here so that we don't cause change. So 2x would be greater than 12. Our x would be greater than 6. As a solution set, you're going to have x in R such that x is greater than 6. Okay, I think that's it. Or sorry, we have not yet finished. 2x minus 5 being less than a negative value of that 7, we're going to have here 2x then minus 5 plus 5 to remove, but you do the same the other side so that you don't cause any change to the inequality. So you have 2x here because this will cancel out. Then here we have less than negative 2, so that we have x divided throughout by 2, that's a negative 1. So you can see that we have two of them. We can't combine this in this format because they are different. We are going to just say that our solution set for this matter will be in the form x being in R such that either x is less than negative 1 or x is greater than 6. That's how you express that if they are different like that for this case, because you can't have here, remember, x is less than this, that means x would be greater than negative 1 would be there, x here, but now you can't write greater than 6 here. It would be hard for someone to understand just write in this format. So for that is done. We look at another number. Let me say we look at 4x minus 1 less than 15. You can try that out. This one says less, we're going to use the other one. The other that should lie positive value of positive value of 15. That's 4x minus 1 is lying there, and negative value of 15. And we solve that. We remove 1, that means we're adding 1 everywhere. Here we have negative 14. If you add 1 here, we remain with 4x. And here we remain with 16. Dividing throughout by 4. Here you're going to have negative 7 out of 2 less than x less than 4 if you divide by 16 by 4. And as a solution set, we're going to have this one. First of all, our 97 out to 2 is the same as, if you divide 7 by 2, what do you have? We just consider the positive. You have going for 3, 6 here, then remainder 1, 3 and 1 out of 2. So we can maybe put negative 3 and 1 out of 2 less than x less than 4. So solution set, we will have x being R such that negative 3 out of 2 less than x less than 4. That would be our solution set. Another number maybe you can try out, b xr 3x minus 1 greater than 5 your answer will be x, that x less than 81 and 1 out of 3, or x greater than 2. You try that out. Try this one out. And thank you for today's video. You can like and subscribe and share. Also, don't forget to comment for maybe where you want me to improve, and maybe to give me or connect with me about the questions I've left for you to try out. Thank you for checking out. Check out for our next video.